Hello, my name is Dwanye here.
I'm Connor Koski.
I'm Erin Norton.
I'm Marisa Rinaldi.
I'm Linley.
And our group project was our birds really dinosaurs. The overview of the research are we're gonna know the background and history, the supporting evidence for the argument, the refuting evidence against the argument, and the conclusion and opinion. One of the most intriguing questions in science is whether birds came from dinosaurs. The dispute hasn't ended today. Evolutionary relationships between birds and dinosaurs are still around. And in fact, birds are closely related to dinosaurs. The question is, how are they related to dinosaurs? Well, the birds represent a branch of the dinosaur lineage that survived the Creotopus crisis and radiated to birds we know today. The first evidence was supported by Thomas Huxley. The first evidence was from 1868 to 1870. He first discovered that dinosaurs had small bird-like ankle joints, small torsos, massive braced hips, a long and mobile neck, and his limbs. He also found that dinosaurs had holes in their bones, supposedly like birds have air sacs in their lungs. The supporting evidence. For past decades, bird-like dinosaurs and dinosaur-like birds have been discovered. The first evidence was by J.H. Ostrich from Yale University. Ostrich described the dinosaur Dianoptis anthropodorus and its similarities to the Archaeopteryx, the first bird, and it was able to form the dino to bird-like hypothesis. A reassessment also showed that bird-like features have been found, like hollow bones that dinosaurs hold, and feet that have 3 functional toes, way before the Archaeopteryx, 50 million years before. The evidence, the similarities between the two, a dinosaur and a bird, a pelvis, elongated arms and forelimbs, tall mammals, large ovals, flexible wrists, and semi-lated capitals, hollow, thin wooded bones, reduced structural stiffness to elonged metatarsus, which are the bones in the feet between the ankle and the toes, S-shaped curved neck, teeth with constructed between the crown and the root, and 4 more vertebrae and incorporated into the hip.
Alright, the first bird we're going to talk about is the Archaeopteryx. The Archaeopteryx was actually the first, speculated to be the very first bird. In Germany, there were about 10 fossils found that kind of pushed the idea of that. They were found in Solnhofen limestone, which Solnhofen is a place in Germany where there's like a shallow watered area about 150 million years ago. What these fossils helped to do was to create the relationship between the dinosaurs and between birds. Through these fossils, they were also able to decide that it was not only reptilian, but also bird-like because of the long bony tail, the 3 claws on each wing, the mouthful of teeth, as well as feathers. In this photo, you can see kind of like a representation of what it would seem to look like. And here was an actual fossil found, and you can see the wings as well as the claws. You can't really see it that well with the left hand, but that is one of the fossils that they found. The next one I want to talk about is the Sinosauropteryx. And this was actually the first fossil found that they saw evidence of feathers. And according to abc.net.au, this animal was not considered a bird, but yet a theropod dinosaur, which a theropod dinosaur is just like a group of bipedal dinosaurs. This is a huge and critical piece of evidence that shows the signs that dinosaurs are beginning to not only look but act like birds. And you'll see here on this next slide, you can't really see that they're feathers because today you think feathers of like the birds now, they're long and feather-like and whatnot, but they're like really small. And you can't see it from the fossil, but when they found the fossils, they could see the evidence of the small feathers and what was looking to evolve into feathers. Now, Maniraptor and Theropods are the most closely related to birds. There's another group of dinosaurs, and I can't really pronounce it, it's something like that. And the similarities were like the shapes of the bones and the way that the eggs were laid and the way that they looked. And also a huge similarity was when they found the fossils, the way that they were shaped, like in brooding poses or in resting postures.
So another supporting piece of evidence that we have that birds are dinosaurs is that there's bird-like eggs found. There's 2 bird-like eggs found in a fossilized female dinosaur, and it produced 2 eggs. And this capability or capacity for having 2 eggs is something that only birds can have. So this was suggesting that there was a dinosaur to bird linkage. And then continuing on with the bird-like eggs, there's a finding published in Paleobiology by Darla Zelensky from the University of Calgary, and she found a new discovery. The new discovery similarities between the actual nest and the eggs themselves. The first similarity was that the eggs were left open to elements. The second was the eggs were pointed, and the third were they were laid vertically. And then also talking about the features of the nest, we know looking at the nest and the shape that it was in, that the mother dug in fresh deposited sand to build a ground to sit on the eggs, so just like how you would see a bird sitting on their eggs. And this was a strong piece of evidence because we could see that there was fossils of the dinosaurs next to the fossils of the eggs. So you can put 2 and 2 together that they were the dinosaurs' eggs. And then feathers. According to a study in the Journal of Science, researchers found hundreds of fossils that had feathers in them. Many people say, well, how were the fossils and the feathers preserved so well? But they were found in fine volcanic ash, so that's why they could see the fossil or the feathers in the fossils. And one in particular was the Velociraptor, and the fossils showed that the Velociraptor had the same feathers attached to where the turkey forearm were attached. So you can see right here that there was bumps right here on the turkey's forearm, that down below you can see that they're the same for the dinosaur as well. And then Mark Noel, a worker at the American Museum of Natural History in New York, said that if Velociraptors were alive today, they'd be just very unusual looking birds. And then 3 more dinosaurs that they found that had feathers. The first one was the Jeholnauronus, so that's the picture right here. The second one is the Archaeopteryx, and then the third one was the Culandoremus. And then the Jeholnauronus, that was a 2-tailed dinosaur that had feathers. The Archaeopteryx had feathers from its head to its tail, and other ones you would just see that had on their wings, so that was a special one. And then the third one was the Culandoremus that was found in Siberia, and it was covered in thin ribbon feathers. And then we have the frame shift hypothesis. So this was a new study conducted in the Journal of Science, and then it says if you number the digits so that 1 is the thumb, 2 is the index, and 3 so on, that the fossil evidence will show that the bird's wings evolved from the dinosaur's hand, and this was shown in fossils. So if you look at the first one, the thumb right here, that was the thumb of the bird's wing. And then if you look at the second one, the finger, the second and third transformed into the wing. So you can kind of see how the dinosaur hand turned into the wing. And then according to information from Harvard Gazette, a new study shows that birds are essentially living dinosaurs with skulls similar to dinosaurs as well. So the goal of this study was to look at the skulls, see how they've changed, and see the similarities and differences between the bird skulls and the dinosaur skulls. So looking at the dinosaurs' brains and the birds' brains, the dinosaurs, they had long snouts, mouths bristling with teeth, and then the birds had larger eyes and larger brains. And then, however, looking at the CT scanners, the researchers were able to track and mark various landmarks on the birds' brains and the dinosaurs' brains. And from the results of this, they show that there's many similarities between the 2 brains. And then here's a chart. The chart shows bone structure of evolution from dinosaurs to birds, and this is from the National Geographic. And as you can see, we have the first dinosaur up there, the Kamavsathos dinosaur. And then we have the Archaeopteryx, which is the bird dinosaur. And then we have the modern bird. And you can see the first dinosaur, you have slim jaw and small teeth. And then the second dinosaur, we also have slim jaw and small teeth. And then progressing to the modern bird, we have slim jaw but no teeth. So you can kind of see how it transitioned. Also, the first dinosaur had a short body. The second one had a short body as well. And then the bird had a short body too. So there are some similarities, but there are also some differences because you would take a big dinosaur and make it to a smaller bird. But as you can see, the transition was very clear. And then the geologic past. According to the Natural History Museum, not all birds that lived during the Mesozoic may have looked as unfamiliar as the Archaeopteryx. Several continents found rocks from the last part of the Cretaceous period that started to provide remains of fossils from other familiar birds. And their descendants are the true heirs of the dinosaurs that lived tens of millions of years ago.
All right, so if birds are really dinosaurs, then, well, the big question is how come they aren't extinct? Researchers have found that there are three main reasons why they aren't extinct now. And that'd be one, because they're so small in size. They're warm-blooded, and also they're able to move very fast. There's a little bit of controversy going on with the birds and dinosaurs viewpoint. So, according to Dr. Tim O'Clarley, who is a professor of geology at Delta College, he wrote an article titled "Dinosaurs versus Birds: The Fossils Don't Lie." In his article, he mentions that there is a man by the name of Sankar Chatterjee, and he is a